and I will present my entire screen. So here is my entire screen, and you guys should nampak the questions. Alright, so one thing yang siapalah baru masuk ni ha? Okay, so one thing yang in this chapter and in chapter depan-depan yang you guys need to know is the most stable ion and the type of stability of an atom lah. So we all know that every atom kalau boleh dia nak jadi octet. Apa tu octet? Is diorang suka sangat nak ada 8 valence electron, which is a complete shell. So muka surat kenapa tulisan saya pelik ni? Muka surat 31, muka surat 31, question number 3. Okay, cepat korang. Okay, next time masuk cepat sikit. So question number 3 cakap, for each of the following elements write the electronic configuration for its most stable ion and state the type of stability. Soalan like this in exam pun usually akan ada 2 or 3 marks. Okay, so always a good thing untuk dalam exam nanti bawa highlighter 2 different color kalau boleh, because usually you akan highlight apa dia punya. So one example is you akan highlight the first, disuruh minta write the electronic configuration for its most stable ion and then state the type of stability. Okay, usually this kind of question 3 marks lah. So because contoh lah, saya takkan bincang semua saya bincang maybe A. So let's do A. So A, so 13 aluminium. Kenapa lah tulisan saya pelik ni? So the first thing usually you akan buat dia punya electronic configuration lah kan. So untuk aluminium is different color. So it is 1s2, 2s2, 2p6 and 3s2 and 3p1. Okay, this is dia punya electronic configuration. Okay, what is the most stable ion dia untuk electronic configuration dia? Okay, untuk electronic configuration of most stable ion, this is bukan ion, okay? This is dia punya atom. Ion is bila dia dah bercharge. So we want to know apa yang dia stable. Okay, so cara nak tahu which one is the most stable one, so dia perlukan 8. So 8 untuk dia stable. So tengok dia punya shell. So this is ya Allah, saya ingat. Okay, sekejap saya connect, disconnect balik. Right, I think this should fix. Okay, it's better now. So cara yang you tengok is you tengok dia punya shell. So this is shell where n equal to 1 and this is the shell where n equal to 2 and this is the shell where n equal to 3 kan. You tengok dia punya principal quantum number kat depan tu. So untuk dia ada 8 valence electron, mana yang lagi senang? So is it dia nak buang? So dia only have 2 ways. So is dia buang ataupun ambil. So either, okay, ini bukan merah ni, plum. Apa color plum? Pink. Yeah. Okay, it's either dia buang these 3. So dia buang 3, dia remove ya Allah. So remove 3 electrons. So dia dapat 8 valence electron here, 8 valence electron here kan. So 6 tambah 2 dah 8. That way, ataupun dia ambil berapa electrons untuk completekan ni jadi 8. So untuk kan complete ni jadi 8, dia perlu add 5 electrons. So untuk tahu which one is the most stable one, usually they involve the smallest amount of electron. The smallest amount of electron is 3 lah. Kalau boleh dia tak nak involving a lot of electron. So untuk aluminium, the most stable punya ions is aluminium 3+. Sebabnya it's easier nak buang 3 elektron yang dekat sini rather than nak ambil 5 elektron. So dia punya electronic configuration for the most stable ion is 1s2, 2s2, 2p6. So this is the most stable electronic configuration. And what type of stability? It is an octet. Untuk type of stability, kita ada sama ada octet ataupun duplet. Itu je. And duplet kita only ada untuk helium, and hydrogen pun rarely ada. Most likely helium lah. Helium, lithium, beryllium. Helium, lithium and beryllium ada octet. Helium which is already an duplet. Sorry, saya cakap octet ke. And then kalau lithium dia boleh jadi lithium plus, which is also a duplet. And also we have beryllium which can form beryllium 2+, where it is also a duplet. Duplet just means that dia punya valence electron is 2. Itu sahaja. Alright. So untuk ni maybe we can do okay, kita teruskan dengan question number 4 lah. Okay, everyone clear so far dengan electronic configuration of most stable ion and type of stability? Okay ke, wahai anak-anakku? Okay ke? Okay, semua okay? Saya tak nampak
Okay,
korang.
sir.
Saya tak tahu korang okay ke tak. Okay. So, kita akan go to question number 4 using Lewis symbol. Show the formation. So, this is another type of question. So, untuk this kind of question for Lewis symbol, we have two type of question. Okay. So, first is the easiest is draw Lewis symbol. Draw Lewis symbol. Ataupun another type of question is like this lah. Dia cakap using Lewis symbol, and then dia suruh show the formation. Okay, so show the formation. So Lewis symbol, you just kena draw the Lewis symbol lah. Macam do step by step. Untuk show the formation, you have to know whether it is ionic bonding, ataupun it is covalent bonding. Okay, most of the question revolves around whether it is ionic or covalent lah. And we also have dative bonding, tapi dative bonding ni very rarely masuk question. And kalau ni pun you just know what is dative bonding lah, where dia bagi electron pairs. Itu sahaja. This is the important part. And macam mana kita nak tahu, macam mana kita nak decide whether it is ionic or covalent is from electronegativity. Nama Y saya tak cukup. Difference. Okay, so kita tengok the two atoms yang involved. Kita tengok the electronegativity difference. Untuk ionic, usually is around 1.7 ke atas, sometimes 1.8 lah. Kalau 1.7 ke atas tu, usually it is ionic bonding. And anything yang lower than the difference is lower than 1.7, usually akan form covalent bonding. Alright. So, let's tengok the question B1. Question B, number 1. Using Lewis symbol, show the formation of MgBr2. Okay, the step yang pertama, since we need to know whether it is ionic or covalent ataupun dative. Okay, but most of the time, don't worry about dative, worry about it is covalent ke ionic. Okay, so untuk MgBr, find dia punya electronegativity difference. So if you look at my camera, I have this periodic table I already give you dekat Discord. And dalam exam, you akan diberi, tapi bukan bentuk periodic table lah, you akan diberi dalam bentuk table biasa. Dia akan bagi tahu elements and dia akan bagi tahu dia punya electronegativity values. So magnesium is 1.3, 1.31, while bromine is 2.96. So let's find the electronegativity difference. Okay, 2.96 minus 1.31. So it is actually 1.65. Okay, even though 1.65 is less than 1.7, kan saya cakap tadi 1.7 usually akan jadi ionic bonding. But this is only a general rules. Okay. Sometimes in actual world, okay, the lines between whether it is ionic or covalent, sometimes it can be blurred. So you don't actually know whether it's ionic or covalent. But a general rules, kalau you guys tengok my camera, manakah? Okay, camera saya. Ni lagi besar. Okay, general rules dia like this lah. Kalau the elements yang react tu, the two atoms tu is one from this side, okay, dari group dari punya S block, and lagi satu element is from P block, which is here, right? Kotak sini. Most likely it is ionic bonding. Okay, metals, this is alkaline metals. Really memang suka untuk donate, and this one area dekat sini memang suka untuk accept electrons. So kalau you tengok element tu dari sini and another they react with element here, most likely it is ionic. Okay, even though electronegativity difference dia is less than 1.7, sebab some books dia cakap 1.7 electronegativity difference baru dia ionic. Some books dia cakap it is 1.8. So it's not really a fixed number yang you guys boleh decide. It is usually you guys tengok dalam dia punya periodic table lah. It is easier. Okay, tengok kalau sini. Kalau lah the two elements, contoh aluminium dengan oxygen, the question number B2, it is covalent sebab dia dekat dia. It's very close together. And even though, okay, kita akan tengok untuk aluminium, even though it is covalent, tapi we will write it as ionic. It is a covalent bonding lah. So, jom kita buat untuk magnesium bromide. So, cara nak buat untuk formation, you have to draw dia punya valence electron, kan? So, magnesium is group 2, which so dia ada dua valence electron. Valence electron you boleh draw as dot ataupun X. Okay, and then bromine. So bromine is group 17. 1, 2, 3, 4, 5, 6, 7. And we have 2 bromine. So you tengok bromine ada 2, you pun kena lukis 2 bromine. So bromine. Okay. So what if kalau saya nak nampak dia lagi cantik, instead of Dua-dua spesies saya guna dot, satu spesies saya guna X. So, you can illustrate the electron transfer better. So, saya buat X. Okay, and then apa yang required in your drawing is you show the electron transfer. Okay, from the magnesium, they donate dia punya electrons to 2 bromine atom, which will result in, okay, since it is ionic, it means it will form ions before dia boleh bergabung. So, cara nak denote an ion, kita denote is Mg, okay, plus, and also untuk bromine, so kita ada 2 bromine kan? So 2 bromine, and we also kena draw dia punya electrons, valence electron. Magnesium 2 plus kan? Magnesium is 2 plus. Yes, magnesium is 2 plus, while bromine is minus. Okay, minus tu duduk sebelah ni. Saya tak cukup tempat. So, okay ke?
Okay.
Any question untuk this? Ada soalan ke? Jangan takut tanya soalan Saya tak makan korang. Saya dah breakfast dah hari ni. Kalau saya tak breakfast lagi, mungkin saya makan korang. Okay, so jom tengok aluminium O3. Okay, so kalau aluminium, dia punya value of electronegativity is 1.6, while oxygen is 3.44. Okay, untuk aluminium and oxygen, it is untuk you punya syllabus, you can consider it as ionic lah, and actually it is a covalent. So kalau you guys tengok the electronegativity difference, okay, is 1.78. So it can be, kalau based on the kita nak terangkan, it can be ionic lah. Tapi kalau you guys akan go on further study on aluminium oxide, it is a covalent bonding. But so far, know that it is an ionic lah. Kita can explain it easier using ionic bonding. So, untuk AlO3, so aluminium is group 13. So aluminium will have 3 valence electron. And berapa banyak aluminium yang you need to draw? Tengoklah, ada aluminium ada 2 kan? So you draw lah 2. So aluminium. Okay, and then oxygen ada 3. So you draw 3 oxygen. Oxygen is group 16. So ada 6. So yeah, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So how does actually aluminium donate dia punya electrons when it doesn't really make sense lah kalau kita tengok. Actually cara dia donate, nak color apa, color hijau lah, is the 2 electrons from the same aluminium will donate to 1, while like this, ini pun dia akan donate to 1, while untuk the third oxygen, which is usually kita akan lukis tengah, is dia akan kongsi electrons from 2 different aluminium. So aluminium yang atas and aluminium yang bawah, thus forming an ionic-ish bond. As example of, kita ada 2 aluminium. Aluminium is 3 plus, and we have 3 oxygen, which is oxygen titik 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 x titik x 2 minus. Okay, cara nak lukis, you only lukis one of them, and this x bermaksud it is an electron that are coming from the aluminium. Okay, so this is cara nak lukis aluminium. Aluminium is quite special, aluminium oxide, because kalau you guys tengok macam ini, macam atas ni, untuk magnesium, okay, we have one, so we have two. So kita make sense lah, kita datang daripada one each of electron datang daripada aluminium, pada magnesium. Untuk aluminium we have two, because dia datang daripada, even though kalau you guys tengok dia datang daripada dua je aluminium. So that's why this is the orang ada cakap it is covalent, or some of it ada cakap it is ionic. And if you remember on chapter 3, this one is also a special one because it is an amphoteric punya compound, which is dia boleh jadi acid ataupun base. Okay, I think that's for question 4. Any question before kita proceed with page 36? Ada soalan ke? Soalan. Okay ke?
Sir,
Ya.
kalau masa exam kan, dia ada bagi ke pasal nilai electronegativity tu?
Yes, absolutely dia akan bagi dekat depan. So kalau you guys tengok buku tutorial korang sini kan, so dalam buku tutorial dia tak bagi kan. So dalam buku tutorial ini memang korang akan dapat dalam exam, simbol atomic number, atomic mass, lepas tu dia punya constant and unit conversion. Itu memang 100% dibagi. And kalau dalam exam, maksudnya contoh exam tu masuk chapter yang ada electronegativity values, this next page akan ada table macam ni, where dia akan bagi tahu simbol and electronegativity values. Okay, kalaulah contoh macam constant yang tak ada dekat sini, dia akan diberi dalam soalan. Contohlah, tapi tiba-tiba korang masuk exam, dia tak bagi values, electronegativity values kan. Jangan cuak, jangan risau. Dalam soalan akan bagi electronegativity values. Dia akan diberi. So korang tak perlu hafal. Macam benda ni semua tak perlu hafal lah. And then dot untuk oksigen boleh letak dekat mana-mana saja. Sekejap, mana oksigen saya tadi? Okay, untuk letak, cara nak lukis dia, so this is how nak lukis. So remember saya bagi tahu hari tu we have 4 tempat saja yang boleh lukis. So we have atas and bawah, and then kiri and kanan. Okay, cara nak tulis dia is kita also follow electron filling principle. We have above Hund's rule. Okay, di mana electrons tu akan fill singly first. So cara nak tulis dia is, sebab oksigen ada 1, 2, 3 ada 6 electron valence. So you letak dulu 1, and then 2, 3 and 4, and then 5 baru you pairkan, and then 6. Okay, doesn't matter yang single punya elektron tu dekat bawah sini ke ataupun sini dengan sini ke, doesn't matter lah, it's still acceptable. Just know that kalau boleh bagi cantik-cantik, which is like this and like this. So you show that these electrons are in pair, these electrons are in pair. So jangan just randomly letak macam ni. This one salah. Okay, 1, 2, 3, 4, 5, 6. Salah. So make sure you letak atas dengan bawah and kiri and kanan only. Make sure there's a separation. That's how you draw a Lewis structure. Every Lewis structure. Okay, boleh ke? Boleh ke? Boleh ke korang? Korang tolong jawab saya. Okay. Alright. So, muka surat berapa lah tadi? 36 kot. Yes, 36. So 36 saya nak tengok ke 30. So tadi 3.1 kita bincang. 3.2 which is molecular shape, right? Molecular shape, you drawing the shape, yang the thing yang you need to know is the drawing and also the angle lah, itu yang penting. Benda ni semua akan benda yang sama ulang-ulang. Just do the gap handout and try untuk buat gap handout tu without the video. Try to buat it yourself. If you can master that, this kind of question is easy marks for you. Sebab question dia, kalau you guys tengok past paper pun, dia benda yang sama je. Okay. Untuk this, which is 4.3 hybridization. So hari tu a lot of people rasa macam hybridization ni macam pening sikit kan. So let's look on hybridization. Okay. The reason why you guys rasa hybridization is a bit pening, sebab banyak benda nak kena buat kan. So the very first thing untuk hybridization is to draw the Lewis structure and then do the hybridization. That's it. Untuk soalan ni, so let me tengok dulu, bincang dulu on question number 2. Okay. Question number 2. Question number 2 C. Okay. 1. So cara dia minta hybridization. Saya nak sebut pun salah lah. Hybridization of the underlying atoms in the following compound. Okay, one way you nak tahu bentuk compound ni is Google, kan? Obviously, saya pun tahu korang tengok Google kan? One way is to draw it back dalam bentuk kembang. So this technique nanti you guys akan belajar dalam chapter berapa tapi semester 2 lah, organic. Where this is a type of yang kita represent a molecule, and there's another type where we represent a molecule using skeletal structure, which is dia bentuk macam ni, like that. So this is ethane. Okay, so cara lukisan ni is how kita senang nak tengok which one is sigma, which one is pi bond lah. So cara lukisan dia, kalau you guys tengok C and then they continue with H3, okay, remember hydrogen only can buat one bond. So it does not make sense untuk CHC. This will never happen. Alright. So hydrogen always have one bond. So kalau CH3 maksudnya carbon dia bersambung dengan 3 hydrogen, which is keliling dia, and then dia akan bersambung to the next carbon lah, because carbon akan have 4 bonds. Carbon usually akan ada 4 bonds untuk completekan dia octet. Baru dia happy. Sebab hydrogen dia only have 1 bond, so that dia jadi happy sebagai duplet. Okay, this is the skeletal structure lah. So type of hybridization of the underlying atoms in the following compound. Okay, hari tu last class I cakap kita nak tengok hybridization, tak tengok lone pairs kan? That one I salah, I'm sorry. We only look sigma bond and lone pairs. So let's figure out how many sigma bond yang ada. And obviously carbon ni tak ada lone pairs. So carbon ni have 1 sigma bond, 2, 3 and 4. It is the same with another carbon lah, dia ada 4. So kalau dia ada 4, sigma bond, dia punya hybridization which automatically terus jadi sp3. Macam mana I know it is sp3? Okay, so we have like this. We have S, and then we have P, 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 and then we have D, 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 D. Okay, D ada 5. So untuk 4, kita ambil dalam 4. So 1, 2, 3, 4. So it is an sp3 like that. So let's look on second which is CH3 CH2. Okay, remember untuk carbon is only ada 4 bonds. So that one dia dah terus, oh my god, I cannot speak today, terus buat double bond for you. Kalau dia tak tulis double bond, okay, it's very simple. So the tips, okay, untuk buat hydrocarbon, this is called hydrocarbon sebab dia ada hydrogen and carbon, right? You guys belajar dalam SPM. Kenapa tali gerak ni? Patutlah. Okay, so the tip is, cara nak tulis dia, tulis dulu carbon. So kita ada 3 carbon, we have 1, 2 and 3. Alright, connect this carbon dulu, connect this carbon. So carbon yang pertama ada 3 hydrogen, so you letak 3 hydrogen. Carbon yang kedua only have 1 hydrogen, tak kisah you letak atas ke bawah, doesn't matter. And carbon ketiga ada 2 hydrogen, so 1, 2, doesn't matter you letak macam mana. Now what you need to do is you need to figure out apa yang belum complete octet. So this one dah complete octet, this one ada 3 je bond, tak complete lagi, this one ada 3 je bond. That's why dia ada double bond. Okay, saya just ajar korang dulu je, because this one untuk this chapter you just don't need to know lah, tapi it's useful untuk second semester nanti. So untuk cari hybridization, so dia highlight this and this. So let's find this hybridization, cari sigma bond. So this one ada 1, 2, 3 and 4. And this one is we have 1 sigma bond, 2 sigma bond, 3 sigma bond, and this one is pi bond. So untuk carbon ni, we have 4 sigma bond which is sp3. But untuk this carbon, we have 3 sigma bond. So ambil lah sampai 3, just 1, 2, 3. It is sp2. Okay, it's very easy like that. Okay, untuk BF3 and CCl4, you guys boleh buat. Okay, now let's look on yang panjang punya style of question, which is question number 3. Okay, soalan nombor 3. Okay, let's pilih how about we pilih C. Okay, kita buat dulu B and then kita buat C. So untuk soalan discard hybridization process yang saya cakap tu is excuse me, yang panjang tu. So untuk this kind of question is the one yang you actually need to spend a little bit of time lah untuk jawab dia. So untuk B, it is BH3. So the first thing yang you need to know is dia punya Lewis structure. And then baru you akan dapat tahu dia punya hybridization. And then baru you akan tahu dia punya geometry lah. Untuk hybridization, we always have first dengan ground state, and then we have excited state. Depends. Kadang-kadang some of it tak ada pun excited state, and then we will have hybrid punya state, hybridized state. Okay. First thing yang you need to faham, okay, let's buat dulu Lewis structure, and then saya akan bagi tahu what actually happens in a bonding. Okay, so Lewis structure dulu. So B and H. Okay, B. So let's tengok boron. Dia punya valence electron is 3, right? 3 electrons. And hydrogen is 1, tapi kita ada 3. So the total valence electron is 6 kan? So nak buat Lewis structure, okay, Lewis structure dia macam biasa, letak the most electropositive atom dekat tengah except hydrogen. Okay, kenapa kita always tak nak letak hydrogen kat tengah? Kita tengah bully hydrogen ke? Tak, sebab remember hydrogen boleh buat only one bond. Kalau you letak tengah, dah tak jadilah molecular structure yang cantik. Jadi hydrogen sambung sebelah, itu saja. So kita letak boron tengah, and then kita susun je ketiga-tiga hydrogen tu dekat keliling dia. Sama juga macam kita buat Lewis structure, atas, bawah, kiri dan kanan. Kalau ada lebih, baru kita sengitkan sikit. Kalau ada 4 and low, kita letak macam tu lah, cantik. So tak kisahlah awak nak letak sini satu, sini satu, sini satu, ataupun awak tak suka dia duduk belah sini, awak nak tulis, awak nak lukis dia belah sini, acceptable. Okay, so what's the next step? The next step is you draw the bonds, and then lepas you draw the bonds, okay, you draw the bonds kan, satu bond ada 2 electrons, right? Satu bond ada 2 electrons, satu sini, satu sini, satu sini, satu sini, satu sini, satu sini. So you have used a total of 6 electron, so tolak 6, dah habis 0. So that's complete lah. So our job is to use all of the valence electron and to make everything either duplet or octet. Okay, so kita dah habis electrons. Hydrogen is happy to be a duplet, so it's okay. Hydrogen dah okay, even though dia tak ada valence electron. Tapi boron, kita tengok ni, it is still tak cukup, right? Dia baru ada 6 electrons. It's still not an octet. Okay, so what we do? Sebenarnya kita dah tak boleh buat apa-apa dah. This is an incomplete octet. Incomplete octet. Okay, sebab kita dah tak boleh nak buat double bond. Sebab remember hydrogen only one bond. Okay, kalaulah boron ni bergabung dengan oksigen ke, nitrogen ke, carbon ke, barulah boleh buat double bond. Barulah dia boleh letak dia punya lone pairs nak jadikan double bond. Sebab kalau you tengok, hydrogen memang dah tak ada dah lone pairs. So dia tak boleh nak donate lone pairs untuk jadikan double bond, nak completekan boron. So boron ni pun kenalah terima seadanya. Okay, dia bersyukur dengan apa yang ada, walaupun dia tak cukup. Okay. So this is dia punya Lewis structure. Okay, and then the question now is describe the hybridization process, right? So I'm gonna padam this. My cute little electrons ni saya padam. So untuk tahu hybridization process, same thing as question 2C, is you need to know dia punya hybridization punya orbitals lah. So we have 3 sigma. Kalau 3 sigma bonds, which is should be 1s and then 1p, 1 lagi 1p. So it is sp2 hybridization. So it is an sp2 hybridization. But this one will not make you a full mark. Okay, because you have to describe macam mana dia jadi hybridization. Okay, untuk a bond form, untuk hybridization, we are usually looking on covalent bonding. So covalent bonding, hiya, apa jadi ni? Okay, covalent bonding. Apa maksud with covalent bonding? With is kita share an electron, share electrons. So untuk share an electrons, it means dia mesti have an unpaired electron. Sharing electrons ataupun sharing unpaired electron each. Okay, so setiap atom kalau boleh dia nak share unpaired electron each. So let's look on boron. So ground state of boron. So untuk boron, macam manalah saya je boron ni. So untuk kita tengok hybridization, kita only explain it central atom, okay? Because central atom yang usually akan do hybridization, okay? The atoms sekeliling sometimes they also do hybridization, but in your syllabus just know that only central atom yang jadi hybridization. Okay, nanti you guys masuk university jangan terkejut when the atoms yang keliling pun happens to be undergo hybridization. Okay, so now let's explain on boron. So boron, dia punya ground state. Okay, boron is 5 electron. Dia ada 5 electron. So it is 1s2, 2s2, 3p1. Okay, dia punya ground state, okay, untuk boron. So untuk boron you just lukis lah sampai 2s. 3. Siapa lah letak 3 ni? Is 2p. So dia punya ground state is 2s and 2p, right? Yes. Okay, one thing yang pihak bahagian matrikulasi want you guys to draw, cara nak draw electrons, hari tu saya ajar draw separuh je kan. Apparently sekarang dia orang nak you guys draw a full arrow. Saya pun tak faham dengan bahagian matrikulasi, because nanti dekat university you guys akan draw a half arrow. So saya tak faham dengan orang atasan. So I just tell you guys to draw a full arrow so that I tak nak nanti you guys lose mark. Sebab bahagian matrikulasi ni dia orang macam tu, kadang dia orang potong markah sebab orang atasan nak you guys lukis full arrow. So lukislah full arrow dah colour lain dah ni. So let's draw in, and then 2p. P ada 3 orbitals. And kita draw dia punya electrons, right? So remember saya cakap pasal covalent bonding, dia share electrons, and kalau boleh dia nak share unpaired electrons. But kalau you guys tengok boron only have 1 unpaired electrons, while dia bonding with 3 hydrogen. Macam mana satu boron ni nak have 3 unpaired electrons untuk ketiga-tiga hydrogen ni? Mana dia nak dapat? So that is when kita perlukan hybridization. So you tulis untuk description you ceritalah ada berapa electrons dekat 2s, dekat 2p macam hari tu. So sekarang saya just lukis saja. And then untuk excited state, colour lain. Okay. So what happened is the boron dia pinjam sikitlah energi daripada orang lain. So ibarat macam ni lah, boron ni nak kahwin dengan 3 hidrogen, tapi dia tak cukup duit. So dia pinjamlah duit daripada mak ayah dia. Okay, so dia jadi excited state, where the energy yang boron ni dapat, dia gerakkan one of the electron dekat hadapan. So let's draw 2s dengan So 2p. So dia gerakkan dia punya electrons ke hadapan. Like that. So this is the punya excited state. Okay. And then bila dia dah cukup tiga-tiga ni, dia dah cukup dah duit untuk kahwin dengan 3 hidrogen. So what happen, dia kena uruskanlah majlis perkahwinan. So dia nak uruskan majlis perkahwinan, dia buatlah hybridization. Hybridize state. So untuk dia buat perkahwinan tu, dia kena gabungkanlah distri 3 orbital ni supaya dia boleh buat bond dengan 3 orbitals. So this is an sp2 sebab dia ambil satu s, 2 dari p. And we have unhybridized p orbital. So inilah dia punya hybrid orbital where electrons tu duduk dengan happily ever after, so that dia boleh buat bond dengan hydrogen. Okay, so and then determine the geometry of the following species. So even though you tahu, because you tahu kan, the sp2 ke sp ke semua dia akan jadi a basic shape. So sp2 you dah tahu dia akan jadi trigonal planar, right? Dia akan jadi trigonal planar. Tapi cara untuk determine the geometry, the soalan dia suruh determine the geometry, yes you kan boleh tulis, tapi untuk full mark you have to show the orbital overlap. So macam mana nak show the orbital overlap? Okay, you draw borons. So I nak draw borons color purple. So draw borons and then draw the orbital overlap. So cara nak lukis hybridized orbital is just lukis like this lah. And you know it is trigonal planar. Okay, so you lukis dalam bentuk trigonal planar. Well, the angle here, angle sini is 120 degrees. Alright, and then you need to show that it is overlapping with the orbital daripada hydrogen. So hydrogen will only have satu electron which is in 1s1. So it makes sense untuk boron overlap dengan orbital s daripada hydrogen. So this is hydrogen. Okay, kalau boleh, so I lukis kecil. Kalau boleh dalam exam you lukis besar. So dekat this overlap ni banyak sikit ruang you nak draw the electrons. So like that lah. Hydrogen and then hydrogen. Okay, so that you can draw electrons yang overlap dekat dalam tu. So we have two, one spin up, one spin down, one spin up, one spin down. Ya, kecil sangat lah. Oh, besar sangat tak? Alright, one spin up and one spin down. Okay, good. Each digerak. Okay, so one spin up, one spin down. Another thing is you also need to label dia punya orbitals. So labeling the orbitals is very easy. You boleh nak buat macam ni. So you draw just sp2 kan, ataupun you nak draw is sp2, also okay lah. Whatever cara you nak label is okay. Even though kalau you nak guna colour, you tulis this colour sp2 pun okay, as long as you punya drawing is kemas. Okay, you have to take in mind, orang yang periksa you punya jawapan, dia bukan periksa kertas you seorang, dia periksa beratus, even thousands of kertas. Imagine dia penat-penat nak draw, nak tanda kertas you and then you lukis buruk-buruk. Okay, even though you betul, dia penat-penat, dia might tersalah nampak and lantak budak ni. Dia bagi salah. Okay. And then you also need to draw the s orbital. Label the s orbital. And another thing is, okay, untuk boron dia ada satu je type of bonds, which is sigma bond. So you also need to label the sigma bond. So what color? Hijau lah. Okay, so EE buruk. So you draw, it is a sigma bond. This also sigma bond. This one is also sigma bond. Okay, and then so you tulis lah, the sp2 hybridization is sp2 hybridization. Teruknya saya tulisan. So sp2 hybridization, dia punya molecular geometry is trigonal planar. Okay, buat ayat penuh lah. So the boron, which has sp2 hybridization, have a molecular geometry of trigonal planar. And then untuk contoh lah, kalau soalan tu is 10 marks, the total of 10 marks, you are trying to get the all of 10 marks. So your drawings also need to be included with a statement where you explain your drawing. So cakap pasal boron have a sp2 hybridization with a molecular geometry of trigonal planar, and then you cerita of it, the sp2 hybridized orbital will form sigma bond with s orbital from hydrogen, and they will form 3 sigma bond lah. So like that. Okay. Untuk this, I think a lot of this are quite similar and quite easy. You boleh buat. Try to buat sampai G semua, and then nanti hantar the tutorials. Untuk double bond, I dah bincang in previous class how we draw the orbital overlap bila kita ada double bonds. Okay, so that's yang saya bincang. Any question ke soalan? Soalan, pertanyaan, inquiry?
Sir.
Okay, untuk final exam, so the way that you guys, dia macam SPM. So contoh KMSW, you guys punya answer, kita orang tak akan semak. The soalan akan diberi contoh lah College Matrikulasi Johor yang akan semak lecturer sana. Sebab lecturer sini tak akan semak you guys punya kertas, orang lain yang akan semak. Yes, minggu ni tak ada amali because kita ada assignment. Saya dah beri assignment dekat Discord, dekat materials. So go ahead, have a look. Okay, noted Vivian. So if kalau tak ada apa-apa, I akan sambung dekat Discord where you guys can tanya soalan and ambil kedatangan. So you guys boleh masuk Discord. Jumpa di sana.